Hello. I am going to be doing homework problems from 3.8 today. Let me do the homework problems first, and then for 3.8, and then we can address any questions that we might have. Okay. So we started with the 3.8 problems last time, and what does this say? Just make sure. Okay. So 3.8, we did last time questions, the first two questions, and so this time I'm going to start with chapter 3.8, question 15. Okay. So on question 15, what's being asked for 3.8, we're looking for, we're being given what they call an idealized two-dimensional object, which is basically our lamina density. Okay. And we're given an area density function. So for this particular one, we have an area density function as a function of x, which is 2x plus 1. Okay. And then we're given different curves. So our first curve, f of x equals x, and our second curve, g of x equals x squared. Okay, so the region that we're going to be looking at, our two-dimensional region, is the region that's bounded by these two curves here. And this is going to be, they tell us, between x equals 0 and x equals 1. Okay, so what they want us to do is they want us to find the mass. They want us to find, let's see, the mass times our moment about x, and our center of mass, and then our moment of y, and then our x coordinate of our center of mass, and our y coordinate for our center of mass. Okay, so these are all the things that we're going to be needing to do. Okay, so the first thing that I like to do when I do these things is I like to graph it out just to kind of visualize what's the area that I'm looking for. Okay, so the first thing, let's go ahead and graph this out. So we're told we're going to go from 0 to 1 in the x direction, which this is 1, sorry. And this is my x-axis, and this is my y-axis. Okay, so here's 1, 1. So y equals x, and I also have, there's my y equals x, and I have my y equals x squared, so it kind of goes like, here's our parabola. All right, so this is our f of x, this is our g of x, this is the area that we're working with here. Okay, so this is, we're given the area density, okay, which is 2x plus 1. So they, basically the mass, our density of this laminar plate varies as a function of x, which is 2x plus 1, how we want to read that. Okay, so the first part that we want to take a look at is what's our mass? So the mass, we're going to integrate from a to b. We're going to integrate our area density times the area of this function here, of this region here. So I'm going from a to b, so this is 0 to 1 in my x direction, 2x plus 1, right? That's my delta area function. And then the area that I'm working with here is basically my upper function minus my lower function. So it's x minus x squared. And I'm doing this as a function of x, dx. Okay, so the first thing I want to do is I want to FOIL these two out. I'll go from 0 to 1, I'm going to FOIL these out, and I'm going to get 2x squared minus 2x cubed plus x minus x squared, and that's all dx. I'm going to combine like terms, so I'm going to get x squared minus 2x cubed plus x dx. And then when I integrate that, I need to show the antiderivative, so I'm going to get 1/3 x cubed minus 1/2 x to the 4th plus 1/2 x squared, and I'm going to evaluate that from 0 to 1. And when I plug in all my values, you know, 1 for x and then 0 for x, and I subtract those two out, I'm going to get my mass for this region here is 1/3. I don't know if they gave us any units, but it would be in mass units if we had them. Okay, so part B says, right, what's our moment about x? We're going to do mass times x. Okay, so what this is, we're going to go again from 0 to 1. Okay, and basically we're looking at, we're going in our x direction. Okay, we're going in our x because we're looking for the our, you know, basically our mass, our moment about mass, and then in the x direction. So this is how far out am I going in the x direction? Okay, this is going to be times our area density, right? And then I'm looking at the area, okay, as a function of x. So I'm looking at, as I go out, I'm looking at, this is going to be my upper function, x minus x squared. And I'm doing this, I'm integrating with respect to x. Okay, so basically, let's plug in what we have, 0 to 1. I've got x times 2x plus 1. That's my delta area function. and then I've got x minus x squared dx. This is like basically what we just did up here, because there's these two functions being multiplied together, and then I have to distribute through it x as I go. Okay. Right, so I FOILed them out, combined like terms, and I have an x that I need to multiply through, so I'm going to do that. Show you some of the algebra. X cubed minus 2x squared plus x squared dx. Right, so this is all just the power rule. I can integrate directly. I have to show the antiderivative, so 1/4 x to the 4th minus 2/5 x to the 5th plus 1/3 x cubed, and we're evaluating from 0 to 1. Okay, once I plug in 1 for x, add everything up, subtract 0 for x, and I'm going to get as my total 11 over 60. Okay, this is my m times x. Okay. Now m times y. Okay, what I'm doing is I'm going to go from a to b. Right, this I'm just write out the formula first. This is my delta area, right? My density function as a function of x in this particular case. Okay, now remember, I think I did a video about this before. So what happens is, right, I've got the area, right, as I'm going, which is going to be we'll write it out as f and g. So this is my f, this is my g function. So I've got my f minus g, right? Okay, so that's where this comes from. That gives me my x direction, okay? And then I need to be able to figure out the y coordinate. So the y coordinate is the average of the two y's. So I'm going to go f plus g divided by 2. So this is f plus g divided by 2, and this is all dx. So f minus g, f plus g is a difference of squares. So this becomes a to b, our density function. This is f squared minus g squared, and that's divided by 2. That divided by 2 comes from when I find the average of my y values. Okay, so when I use this f squared minus g squared, it comes from, right, I'm taking the average of the y, I'm taking basically the area, this is our dA, right, but I want to be able to find the y coordinate. So before when we were looking for the x, right, I did the area, this is my dA, right, and I said, where are we in the x direction? This says, where are we in the y direction? So I'm going to average those two y values, okay? So when I put these all together, I get f squared minus g squared. So plugging in, right, so our f is our upper function, that's our x, and our g is our lower function, that's our x squared. Don't forget it's x squared squared, okay? So when I plug all this stuff in, so a to b, I'm going to go from 0 to 1. Okay? My delta area function is 2x plus 1 times, right, I'm going to go x squared, so let's write it out. So x squared minus x squared squared all over 2 dx, which looks like 0 to 1, 2x plus 1, right? X squared is x squared squared is x to the 4th. This is all over 2 dx. Now I need to FOIL these out. I can take out the 1/2, so we'll do that first. 1/2, 0 to 1. I'm going to FOIL these out. Basically, what I'm going to get is, let's see, 2x cubed minus 2x to the 5th plus x squared minus x to the 4th dx. Okay, I factored out this 1/2 comes out, so this becomes, right, I'm FOILing these terms out, and I get that. Okay, I'm going to do the power rule when I go to integrate, so I'm going to get 1/2 times, so 1/2 is from before, x to the 4th over 2 minus x to the 6th over 3 plus x to the 3rd over 3 minus x to the 5th over 5. And I'm going to evaluate that from 0 to 1. And when I plug in all my values, right, I plug in 1 for x, and I subtract out 0 for x, what I'm going to get is 3 over 20. Don't forget to multiply by the 1/2 that we had before. All right, you couldn't see all that. D, part D says, what's our x coordinate for the center of mass? Which means I'm going to take my answer from B, which is my moment times x, my mass times x, I'm going to divide it by the mass. Now remember, I can't just cancel things out ahead of time because I have to integrate first. Okay, so when I go to do this, you can see it. So I take my answer from before and I say 11 over 60 divided by the mass that we found in part A, by 1/3, and that's going to give me 11 over 20. Okay, that gives you my coordinate, my x coordinate, and then E is the same way, but for y, it's going to be my. So this is our answer from part C divided by the mass from part A. So this is going to be 3 over 20 divided by 1 over 3. And I'm going to get 1 over 20. Okay, so that's how we work it through. That was question 3.8, chapter 3.8, question 15. Okay, so let's move on to question 16. So this is chapter 3.8, question 16. Okay, so let's read out what's our question for 16. So in this one, we're given that the area that we're working with is a rectangle. And it has vertices 1, 1, 1, 5, 6, 5, and 6, 1. And we're given our area delta, our density area function is e to the x, and it's a function of x. Okay, so again, what we want to do is be able to figure out all those different pieces that we did before, which is our total mass, our basically our x coordinate of the moment, our y, and then essentially work it through there. So we've got this rectangle here. So the first thing I'm going to do is I'm going to plot it out. 2, 3, 4, 5, 6. So my first coordinate is 1, 1. My next coordinate is 1, 5. My next coordinate is 6, 5. And then I have 6, 1. So here's my rectangle here. Okay. So basically, this is 1, this is 6. So on my x-axis, this gives me my bounds for integration. So from a to b, right? I'm going to integrate from 1 to 6, right? And then I'm dealing with these functions right here. This is my upper function, which we'll call y equals 5. I've got this function here, which is y equals 1. So I wanted to be able to translate my rectangle into multiple functions and bounds for integration. Okay, it's going to help me think about what I need to do. So remember our mass, our overall mass for the system, a to b, I'm going to integrate my area density times the area. So I'm going from 1 to 6, and my area density was given to me before as e to the x, and the area is my upper function minus my lower function. And I'm integrating that with respect to x. So this is 4. So this is 4 e to the x, and I'm integrating from 1 to 6. So I'm going to get 4e to the x, and I'm going to go from 1 to 6. Okay. So now when I go to evaluate this, I'm going to say 4e to the 6 minus 4e to the 1. Okay, and this is my mass for this structure right here, this area right there. Okay. Part B says, okay, what's our moment about x? Okay, so again, this, I'm going to go from a to b. I'm going x, where am I along the x-axis, times my area density function, which is a function of x. I'm going to do my upper function, right, which is f minus g dx. So let's plug things in. So my a to b, so I'm going from 1 to 6, x times my area density function, e to the x. And then my upper minus my lower, again, is going to be 5 minus 1 dx. Okay. So let's multiply these things out. So I'm going to get from 1 to 6, I'm going to go from 4x e to the x dx. Okay, so now when I want to be able to integrate this, what I'm looking at is integration by parts. Okay, so I'm going to choose my u as x, which makes my du 1 times dx. So my dv is equal to e to the x dx. I have to integrate in order to get v, which is going to be e to the x. Okay, and remember our integration by parts is uv minus the integral of v du. Okay, so let's plug things in based on what we have. So my u is x times v e to the x minus e to the x times du dx. Okay, which is going to give us 4. And this whole thing was being multiplied by 4. Oops, and I actually had a 4 out from before. Because you can think about it as we factored out the 4 right here, and this is the part that I did integration by parts with. So this is 4 times all of this stuff right here. So I've got a 4 times x e to the x. Oops, sorry, I wrote that down already. Minus e to the x. And I'm going to integrate from 1 to 6. Okay, so what I get is 4 times 6 e to the 6 minus 4 e to the 6 minus 4 e to the 1 minus 4 e to the 1. So my total answer for mx is going to equal 24 e to the 6 minus 4 e to the 6. I know these are just numbers. I could plug it into my calculator and get like a decimal number on it, but I'm going to leave things in terms of e. Okay, so now here I'm looking for my. Okay, so again, I'm going from a to b. Okay, I'm doing my area density function. Okay, and I'm looking at f squared minus g squared divided by 2 dx. Remember, we just talked about that, where this comes from. Okay, so it's a multiplication of basically the area, okay, that we're working with, which is our f minus g, and the average f plus g divided by 2 is going to give us f plus g divided by 2 is going to give me my f plus g divided by 2 is going to give me my average y coordinate, which is what we're looking at here. But I multiplied all those together, I filled them, and I got f squared minus g squared divided by 2 comes from our average y. Okay, so let's plug things in. So I'm going to go from 1 to 6. E to the x is our area density function. F squared, that's 5 squared, minus 1 squared divided by 2 dx. This is 25 minus 1, that's 24, divided by 2 is 12. So we're looking at going from 1 to 6, e to the x times 12 dx. That's a nice straightforward integration. So I'm going to get 12 e to the x, and I'm going to integrate from evaluate from 1 to 6, which is going to give me 12 e to the 6 minus 12 e to the 1. And this is my my mass times my y coordinate of the center of mass. Okay, so part D and E, basically we're looking at my x coordinate for the center of mass is just my mass times my x coordinate divided by mass. So I'm going to take the answer that I had from part B, which was 24 e to the 6 minus 4 e to the 6 divided by the mass that we found in part A. Okay, I'm going to put that into here. 4 e to the 6 minus 4 e to the 1. Okay, and I can do a bunch of things to simplify it out. I can leave it like this. These are ultimately just numbers. Okay, so if I were to actually plug it into my calculator, I think I get something like 5.13 when I do it out. Okay. You can leave it like this, or you can put it into your calculator. You should do this part first, and then you can show the decimal version of it. Okay, so part E says look for y bar. It's the same thing that we did for x. I'm going to take my mass times y, and I'm going to divide it by mass. Okay, so this is going to give me the answer that I got in part C. 12 e to the 6 minus 12 e to the 1 all over 4 e to the 6 minus 4 e to the 1. Okay, this one I can actually do some simplification. So I've got 12, I'm going to factor out the 12 e to the 6 minus e to the 1. Divided by 4, I'm going to factor out the 4 e to the 6 minus e to the 1. Right, these will cancel. 12 divided by 4 is equal to 3. Okay, it just so happened that I was able to do that. These are really just numbers. Okay, so you could leave it like this as your answer, but you can also simplify it like that. And that gives us question 16. Okay, so let's move on. Question 21 from chapter 3.8. 21 is slightly different. I don't think this one's on the final, but it helps to actually know how to do it. So let's bring up our exact question. So the exact question for this one is, we want find the centroid of the region given in an example. This is an example from the book 3.8.7. We'll write down what those things are in just a minute. Okay, so we're looking for a centroid. So a centroid is different than a laminar surface. So a laminar surface, we're given the area density function. And the centroid is essentially the center of the area. Okay, so what we're going to be, instead of dividing by the mass, we're going to be dividing by the area. But that also means I need to find out what the area is of my region. And we're going to assume that the basically that the area density function okay, it's essentially it's essentially a constant. Okay, so we kind of don't have to worry about it too much. Okay, so let's write down what our parameters were from this particular question. So y equals x squared, x equals 2, and y equals 1. So we're looking for the region bounded by these different graphs here. So the first thing I'm going to do is I'm going to plot it out just so I can visualize. Yes, this is 1, 2, 3, 4. So y equals 1. Here's y equals 1. Okay, x equals 2. X equals 2 is our vertical line. So this is x equals 2, and I've got y equals x squared. So 0, 0, 1, 1, and then 2, 4. So I'm looking at a graph, parabolic graph that goes like this. And this is x squared. So then the region that we're looking for is the region bounded by all three of these. So we're looking like this. Okay, that's the, I want to find the centroid. Centroid is going to be a coordinate, an xy coordinate. It's basically the center of the area. Okay. Right. So let's keep looking. So let's write down some things. So centroid, we look at x bar. We're going to divide by our area. I'm going to integrate from a to b. In this case, our a is going to be 1, and our b is going to be 2, because that was where all of these different functions intersected each other. And I'm looking at x, where am I along the x-axis? And I'm going to go my upper function minus my lower function and dx. Okay, so now you notice I don't have basically, how did I write this down here? So I don't really have like an area density function. My area density function is assumed to be constant throughout. Okay, so I basically don't have to worry about doing that. Yeah, so this is constant. I should actually have written this as like, let's call it a 1. Oops. Call it a 1. So it's essentially a constant area density function as we go. Okay, so what I'm going to do is my y, so this, my centroid is x, so my centroid for y is going to look like 1 over a, and then go from a to b. Now I'm going to go, this is going to be f minus g. This is my, where am I along, what's my area? So this is my area function here. And I need to do my average y value, and I'm going to be integrating that with respect to x. Okay. Notice how we're dividing by a. This was like in the previous example when we divided by the mass. Okay. But notice how I don't have a delta area function. My delta area function is considered a constant term. It's like a 1. So it's basically going to cancel out. Okay, so the first thing I want to be able to find is, what's my area? What's the area that we're actually doing this? So I need to integrate from a to b, and I have to look at my upper function minus my lower function, and I'm going to integrate with respect to x. Okay, so let's go ahead and plug that in. So I'm going to integrate from 1 to 2. My upper function is my parabola, x squared. My lower function is this y equals 1 dx. Okay, so I'm just going to integrate x squared minus 1 dx, and I can use the power rule for that. So I'm going to get 1/3 x cubed minus x, and I'm going to go from 1 to 2. Make sure that you show the antiderivative when you do these things. Okay, so when I plug in 2, when I plug in, actually we'll just show it. So I'm going to get 1/3 2 cubed minus 2, and that keeps breaking, minus 1/3 1 cubed minus 1. Okay, and when I basically multiply everything out and do it, I'm going to get 4/3 is our area. Okay, that's the number that I'm going to be dividing each of these things by. So my x bar, okay, my x coordinate for the centroid, we're looking at, I'm going to go from a to b. I'm going to say x times x squared minus 1 dx, right? So this is what we talked about before. And then I'm going to divide it by, okay, my area here. Okay. So this is going to be, I'm going to go from 1 to 2. I'm going to say, I'm going to multiply 2. Here I'm going to get x cubed minus x dx. Okay, and I'm going to divide that by 4/3. Okay, so what I'm going to get is 1/4 x to the 4th minus 1/2 x squared evaluated from 1 to 2, all divided by 4/3. And when I multiply everything through, okay, I substitute in 2 for x, I raise it to the 4th power, divide by 4, so on and so forth, and I divide everything by 4/3, my x bar, my x coordinate for the centroid is 1.6875. This gives me the x coordinate for my centroid. My y bar, I'm going to do the same thing. I'm going to go from A to B, right? I need to do my area, which is f minus g, right? This is going to be, and my average of the y's, f plus g divided by 2. So this looks like A to B, f squared minus g squared. This is our difference of squares, and that's 1/2 dx. And then this whole thing is going to be now divided by our area. So let's plug in our values. First, I'm going to go from 1 to 2. 1/2 x squared squared minus 1 squared dx is going to give me 1/2 integration from 1 to 2 x to the 4th minus 1 dx. This is all power rule. I can then just use that. So I'm going to get 1/10 x to the 5th minus 1/2 x evaluated from 1 to 2. And when I plug in everything, oh, and then all of this is going to be divided by 4/3 to give us y. Let's write this out. Divided by 4/3. And 4/3. So when I multiply it all the way out, let's do this. I'm going to go 1/10 to the 5th minus 1/2 times 2 minus 1/10, 1 to the 5th minus 1/2 times 1, all divided by 4/3. What I get in the end, my y bar is equal to 1.95. So this is a coordinate. So let's write down, we'll summarize it. Sorry, I don't think you can see that. 1.95. So our coordinates, so our centroid, let's summarize it right here. Right, our x coordinate is 1.687, and our y coordinate is 1.95. It should make sense with our graph. Okay, so I'm going to put a box around that because that's our total answer. So our graph says 1.6. So I'm going from 1 to 2. So 1.6 is roughly like right about here. 1.95 is almost 2, so it's right about here. So this right here is the centroid. Okay, so when you, a good cross-check when you're doing all this work is to actually plot it on your graph and to see, does it make sense? Is it in the right ballpark, right? If the answer that I got here landed me in like the 3rd quadrant, or it landed me way outside of my shaded region, maybe I made a math mistake somewhere and I should go back and check it. Okay, so that's the end of answers for working through for chapter 3.8. So I'm going to stop the recording just for a minute so that I can save it, and then we'll start up on chapter 3.9.